When I see these truth and lie problems, I sort of think there's kind of two possibilities for each person. So there's sort of 2 to the 6 possibilities of what the configuration is. You know, like they could all be super spies who tell the truth, or they could all be villains, or something in between. Lucia says you could think about the people as in pairs rather than a circle for the first part. I like that as a way of breaking down the problem. To think about people just in the pair of the person opposite them and not. And a couple of people have said people opposite have to be the same type. Let's have a think about that. So let's look at P1 and P4. That's one of the pairs. So P1 says P4 is telling the truth. And the way I break this down into cases, there are lots of different ways to break this into cases, but I'd say either P1 is a super spy and is telling the truth, in which case, well, P1 is a super spy, and also P4 would have to be a super spy. And then I'd have to check that makes sense, because P4 says, you know, I've got to check that against what P4 actually says. P4 says P1 is telling the truth. Oh, and that's okay. That checks out. So that's my either, or there's another possibility. Hang on, am I writing behind my head? Not quite. There's another possibility. P1 is an evil villain. In which case, so is P4. Because P1 says that P4 is telling the truth, but P1's a villain and is lying. Okay. So P1 and P4, both villains. So I think there's 3 pairs. There's the P1, P4 pair. They could be, I'm sort of making up notation as I go along here. They could be a spy and a spy, or they could be a villain and a villain. And we've also got a P2, P5 pair. They could be SS or VV. And we've got a P3, P6 pair. They could be spy or villain. Okay. Yes, so there's this thing about independent choices here. Each pair could be one of these possibilities. And the thing you do when you have independent possibilities is you multiply them together. And chat's actually, people voting in that poll have actually kind of agreed, I think, on picking out 2 to the power of 3 is 8. And that's right. This is 2 to the power of 3 equals 8. 3 independent pairs, each with 2 possibilities. Okay, so part A, I like that they split down into pairs. Part B, they each say the person to my left is lying. So now their statements kind of all join up in a loop. They're all talking about the person to their left. So rather than splitting them into pairs, we've got to think about what goes on for all of these. Okay, there's some suggestions coming up in chat for how we might. I'm always interested in how we get started with problems like this. You know, I've kind of never seen a truth-lie problem like this one before. I think the setup's been made up by the question setter, especially for this question, right? To have it's kind of like a truth or lie problem, but the people are sitting in a circle and we're now using that fact that they're in a circle all lined up around like that. It's quite a unique setup that I haven't seen anywhere before. If someone's seen this somewhere before, let me know. Yeah, so somebody asked about textbooks. I'm gonna get to your question. So don't worry, I'm gonna get there. Yeah, people think that maybe they have to alternate. Can anyone explain to me why they have to alternate? So that's a claim I've seen a couple of times coming up. If 2 sitting next to each other are the same, then if they're okay, so suppose 2 people are sitting next to each other and they're the same. If they're super spies, then the one on the right would be lying, because they'd say, well, the person to my left is lying. That's not right. The person to the left is a super spy. If they're both villains, then the person to the right is saying, well, the person to my left is lying, but that's a true statement. Villains are never supposed to tell the truth. Villains can't be next to each other. So let's put that fact. Villains can't be next to each other. because if we had a villain and a villain, left and right, sitting like this person would be saying the person to my left is lying. And confusingly, that's a true statement which villains are not allowed to do. So the fact that that's true is what's wrong with this scenario. Villains never tell the truth, even about other villains. So similarly, super spies can't be next to each other. Oh, sorry for the handwriting. So must alternate. I think that means there are two possibilities, either going spy villain spy or villain spy villain. Brilliant. Okay, I like that. If you want an extension to this, this is just the first half of the problem. There's an extension in the 007 worksheet. So if you go back to last week and look at the full question, there's an extension to this with n people instead of 6 people. And you can imagine that the patterns that you get out are a little bit different depending on what happens when you go all the way around. Okay, for example, it's only possible to alternate if you have an even number of people. And there's facts a little bit like that in the second half of this question. But I'm gonna move on now. So I set this warm-up activity because it's kind of similar to what we're about to do for this prime number question. We've got this difference of two squares thing. Difference of two squares is one of my absolute favourite bits of algebra. It sounds really simple, but then you can use it really flexibly in lots of different situations. Just great. People who have been to a few live streams might have seen a question where we used this to work out that some numbers were not prime numbers by spotting we could factorise them like this, by writing them as the difference of two squares. That was good fun. People who haven't seen that, you're going to love the live stream that's just replays of bonus questions that we're going to do. Okay, factorising this one, I think this is a minus b times something like this. So I reckon it's got an a minus b factor, inspired by the fact that when a equals b, there's a factor there. This one I would use difference of two squares twice, I think. And hey, look, this one is a multiple of a minus b as well. That turns out to be what's going on for the rest of this question. For this one, I'd say p of 1, this is a reference back to the factor theorem, which we're supposed to know, that if a is a root, then x minus a is a factor of the polynomial. Okay, if p of x is xn plus 1, then we want p of minus 1 to be 0, so we want minus 1 to the n plus 1 to be 0. That happens if n is even integer. As several people point out in chat, I don't mean hot over here. Oops. Thank you, chat. So when you expand and simplify this, I'd go through and multiply out. So I'd go and multiply out. That'll be my approach to this. So if I multiply out all of these terms, and I do it quite systematically, there's loads of cancellation. And you end up with a to the n minus 1 minus b to the n minus n plus, come on James, a to the n plus 1 minus b to the n plus 1. Part 2, I'll just talk through part 2, I think. 3 has the property that it's 1 less than a square number. Are there any other prime numbers with this property? People in chat seem to be saying no, we think there's not any other primes with this property. Because if you're 1 less than a square number, then that means that you are n squared minus 1 for some integer n. And n squared minus 1 famously factorises as n minus 1 times n plus 1, difference of two squares. And it's possible to write that down and then get too excited and say, so not prime. But actually that's not quite true, right? Partly because, I mean, we've seen that 3 is an example where it is prime. worth thinking quite carefully about what's going on there. This looks like we've factorised the number into two distinct factors, but remember, a prime number is a number that can only be factorised as 1 times itself, and that could be a possibility. So could be, so this is not prime unless m minus 1 is 1 or m plus 1 is 1. And actually one of these cases, m minus 1 is 1. What have I done? I was hoping to get a 3 out here. Oh yeah, I was going to get n is 1, n is 1 plus 1, which is 2. 1 plus 1 is 2, welcome to the live stream. Or n is 0. And that doesn't give you much of a prime. Okay. I guess we should check that. So these are my two cases. Maybe this is not a prime number. If n minus 1 is 1, then n is 2. So we've got n squared minus 1 would be 3. That's the one we already found. And there's kind of this other case here that if this is 1, I guess we should consider that. Then n would be 0. So n squared minus 1 is minus 1. And that's not prime for a kind of different reason. I'm going to see if I can think of any. So I guess I'll think about some small cube numbers. Small cubes? I guess there's like 1 cubed plus 2 plus 1. That's 2, which is prime. 2 cubed plus 1 is 9, which is not prime. 3 cubed plus 1 is 28, which is definitely not prime. 4 cubed plus 1 is 65, which is not prime. People in chat are saying we can factorise this again. We can factorise, this would be n cubed plus 1, and then that is equal to n plus 1 times, some sort of factor. Somebody in chat has just written out what that is. Thank you, anonymous person in chat. Is this a prime number? Well, we've sort of factorised it. So this is pretty bad news if it's going to be a prime number. So it's kind of going to be not prime unless, I suppose there's two cases again, either n plus 1 could be 1 or n squared minus n could be 1. Okay, this looks a bit like 3 cases to me. This looks like n equals 0 for the first one, or what's the solution to this one? N equals 0 or n equals 1. So here are some cases, actually only 2 cases that I should go away and check. 0 cubed plus 1 is 1, which is not really a prime, and 1 cubed plus 1 is the one we already found. That's 2. So my answer to this one is the only prime that's 1 more than the cube is 1 plus 1, which is 2. Okay, I had to think a little bit about the 0 case again. I was a little bit worried that that could give me a prime, but by convention, 1 is not a prime number. Haley wants to use the factorisation from part 1 to do part 4, and I'd been wondering when we were going to use part 1, so I quite like this suggestion, Haley. So yeah, let's go back and use part 1. There's a little bit of a problem that the first thing that I tried anyway, I'm going to clean this up a bit. First thing I tried didn't work. Let me show you that. This looks like the thing we had before, right? This was equal to a to the n plus 1 minus b to the n plus 1, which looks like this. Exciting, right? But there's kind of a problem in here that the first time I saw this, I wanted to say, well, I'll just take a as 3, b is 2, and n is 2014, and then off I go. I've got 3 to the 2015 minus 2 to the 2015 is equal to a minus b times all this stuff, 3 to the n plus 3 to the n minus 1 times 2 plus dot 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 plus 2 to the n. N is 2014. Okay, loads of writing down. This thing's factorised, so hang on. I want to say it's not prime, but I can't because this is unfortunately 1. And even primes are a multiple of 1. So yeah, I guess this is quite tempting to think that, you know, I tried to factorise it and I got 1 times itself. And then it's quite tempting to think, well, I tried to factorise it and I got 1 times itself. That's what primes do. So maybe this number is a prime number. But in fact, it's more complicated than that, because there are other more clever ways we can try to factorise it. I'm going to read one from chat. Okay, so here's what I've seen someone else do, and it's also what I tried to do eventually on this problem, which is after I tried A as 3, B as 2, and got out this 1, you know, pretty annoying, I thought, well, maybe I should rethink and think about this 3 to the 2015. I could think about that as 3 to the 5. You know, 2015 is not prime, so I could think about that as 3 to the 5 to the power of 401 minus 2 to the 5 to the 403, sorry, to the 403. Okay, my problem here was that I ended up with a 3 minus 2 in this bracket, which I don't really like, because it's 1. Well, it's not the sort of thing I was going for. But if I write it like this, 3 to the 5 to the 403 minus 2 to the 5 to the 403, then that would be equal to 3 to the 5 minus 2 to the 5, again using part 1, times, deep breath, 3 to the 5 to the 402, plus 3 to the 5 to the 401 times 2 to the 5, plus dot dot dot, plus 2 to the 5 to the 402, close bracket. And now I've written it in terms of a product of two numbers that aren't 1 and aren't the number itself. Something I spotted when I looked at this, I just like messing around with these expressions when I see them, is that it's kind of almost k cubed plus 3k squared plus 3k plus 1. I guess I've done a lot of multiplying out with binomial coefficients before, so I get excited when I see numbers a bit like binomial coefficients. You see, that would be k plus 1 cubed. It's not that though. It's k plus 1 cubed, but then minus, I'd have to subtract a k squared plus k, so I'd have to do that. So it's actually k plus 1 cubed minus k squared minus k, but hang on, I can factorise that as well, right? So that would be k plus 1 cubed minus k plus 1. Is this useful? I don't know. Is this going anywhere? I don't know, but we're trying stuff out. Okay, I think I could probably simplify that a little bit more. Let's go over here. That would be k plus 1. I could pull out a factor of k plus 1 and then write it as k squared plus k plus 1. I don't know if this is helpful or not. It's probably not helpful. Yeah, k plus 1 is a factor. Maybe this is helpful, maybe not. This looks a little bit like the things going on in part 1. Could that be a cube number? I'd have to think really, really hard. You see, I haven't really engaged with, is this a cube number yet? So this factorising hasn't really helped me get closer to this. Okay. People in chat there have had a different idea, and being able to pivot from one idea to another is an important skill, again. To say that this k plus 1 idea was pretty good, this is almost k plus 1 cubed. In fact, it's less than k plus 1 cubed. Why is it less than k plus 1 cubed? That's a cube number. That's a cube number. Why is it less than k plus 1 cubed? Because of the algebra we just wrote down, I suppose. K plus 1 is k plus 1 cubed minus k plus 1, where this is some positive thing, because k is a positive integer. So it's less than k plus 1 cubed, but it's also bigger than k cubed, because it's k cubed plus some positive things. That means it's between k cubed and k plus 1 cubed. Hang on, it's between two cube numbers? It's between two consecutive cube numbers, so it can't be a cube number. It's between, okay. Okay, so no matter what k is, this quantity is going to be somewhere between k cubed and k plus 1 cubed. So it can't be a cube. Okay, so we've got x squared is 2 times x plus 1. So x to the 4 is going to be 2x squared plus x. Oh, fantastic! I've got a mark already, I think, for showing this. I think it's probably, maybe I'm going to also write down that's equal to x plus 2x squared. Really get that going. and I'm going to go and x to the 5 is equal to, for my next trick, x squared plus 2x cubed. And this is not quite what I've been asked to show. I suppose I need to reuse this fact. I've got an x squared, which I'm okay with. I've got this x cubed though, which I don't really like. But luckily I know a fact about x cubed. It's equal to 2x plus 1. So I can use that to reduce the order and write this out, 4x plus 2. Oh, fantastic, that's this. Tick. Right, okay, great. So we've written both of these things as quadratics. In part 1 we showed these things, and now it would like us to show that these relationships are true. And I think the way I'd start messing around with this is to think, well, these things on the left, these are facts about x to the k plus 1, and these things on the right are facts about x to the k. We've got something like x to the k is equal to, oh, we've got exactly this, haven't we? We've got x to the k is a to the k plus b, oh no, a subscript k plus b subscript k x plus c subscript k x squared. We know that x to the k plus 1 is equal to a k plus 1 plus b k plus 1 x plus c k plus 1 x squared. Okay, so somehow these are the facts we know. And this is what we would like to show. Want to show. What? Okay. And it's sort of a similar idea, I suppose, to what we were doing before. We're just going to try and multiply by x and see what happens. Here's what happens. So if I take this one, x to the k, so I can multiply both sides by x again, like we were doing before. I get something like this, but now I could use the facts that we know about x cubed. Sorry, we had another fact that I didn't list. X cubed is equal to 2x plus 1, that's a very good fact. Okay, so if we use that fact, then we get this is equal to akx plus bkx squared plus ck 2x plus 1. Okay, and then I think we can compare coefficients with stuff, this thing over here. And if we can compare those coefficients, then we get out the x squared coefficient is, well, it's ck plus 1, but it's also bk down here, so that's this. The x coefficient is bk plus 1 over here, but it's also ak plus 2ck from this equation. And finally the constant term is ak plus 1 over here, but it's also ck over here. Cool. So we're going to use the previous part of the question now. Here's some more algebra they'd like us to do. So it defines a new thing, dk. So this is a new sequence and each dk, the kth term in that sequence, is going to be defined by the ak plus ck minus bk. Okay, and I've got up here, I've put those things that we just proved. And I reckon that's going to be relevant because they want us to show something about dk plus 1 in terms of dk. Yeah, so people are mentioning induction in the comments, which is fine. If you know about induction and you want to use induction or the language around induction for this, that's fine. I think this question's been written quite carefully so that even if you haven't seen induction, it's trying to get you through the logical steps of how a proof by induction might work. So it actually doesn't matter if you've never heard of proof by induction, then we're still helping you through the process of what you would do. So this thing about relating each thing to the previous thing, and then looking all the way back to the start. So here's how I would approach this algebra. I want to show that dk plus 1 is equal to minus dk. So I start by writing out what dk plus 1 is. We know that dk plus 1, people who have seen the live stream before and know that I'm a fan of writing just a couple of words to explain what you're doing. Dk plus 1 is a k plus 1 plus c k plus 1 minus b k plus 1. And from part 2, this is ck here. This ak plus 1 is equal to ck, using that fact. This ck plus 1 is going to be bk. And this bk plus 1 is going to be ak plus 2ck. Okay, so I should rearrange this because I just like simplifying things when I see stuff like this. And I get a bk, I'll get minus ck, and I'll get a minus ak. Oh, and fantastic, that is minus dk as required or something. And then I've just written a few words to show that I've started here. I'm going through. There we go. Okay, so, and there's a hence show. Hence has got a special meaning in questions like this, in maths and other exams, and in, I guess, general mathematics. Hence means using the previous part, or using the thing we just did. So here we're being told to show that this, and then hence show that this next thing is true. What's the relationship? Well, it looks a little bit like somebody's rearranged this a plus c minus b thing to move the b onto the other side. A bit suspicious. I suppose we're being asked. To check that we've understood this fact about dk plus 1 being minus dk. So, for example, like d of 37 is going to be minus d36. It's going to be minus is plus. d35 is going to be minus d34. So this kind of alternating signs thing feels like it's coming out of all these minus signs together. I'm not quite done though. I need to check that this isn't plus or minus 2 or plus or minus 3 or something like that, that it's plus or minus 1. Okay, if that makes sense. So I get picking up a lot of minus signs along the way each time I move from one d to the next d. Right. What's an early value of d? So what is, let's have a look, what is d1 or d0? Does d0 make sense to think about? Well, so d0 would involve a0 plus c0 minus b0. And those were the coefficients for what x to the 0 was. X to the 0 is 1 plus no x's plus no x squared. So this would be 1 plus 0 minus 0. That was 1. Okay, so that's pretty good news. D1, well, we've just shown with a lot of algebra that minus d0 is minus 1. Then afterwards, d2 will be 1, d3 will be minus 1, and so on, and until we get to 34. So the signs alternate, and it starts at 1. That means that it's plus or minus 1. A lot of thinking to make sure we write that down in a neat way. Neatly, dk is minus 1 to the k. Starts at 1. Starts at 1, alternate signs. If it started at minus 1, I think I'd want an extra minus sign in here. But I think I've got the right number of minus signs. Okay. And then slightly rearranging that to move the b onto the other side gives me this statement. Okay, great. So I want to show, this fact here is I want to show that ak plus 1 plus ck plus 1 plus ak plus 2 plus ck plus 2 is equal to ak plus 3 plus ck plus 3. Okay, I'm going to use the things in the box to simplify this. Here's the right hand side. Right hand side of this is ak plus 3 plus ck plus 3, and that's equal to, I'm going to use this fact first, using, I guess we've had this a few times before in the live stream. It's a little bit annoying that this uses some k's in the subscripts, and the fact I'm about to use it in uses k's, technically they're different k's, or it's not quite the same thing. Spiritually, this means a at some subscript is just equal to the previous c. So this just means I can write this thing for this a. Okay, and this ck plus 3 is going to be b with the previous subscript. Okay, we've had stuff before about how this this can be confusing using k's in your facts and k's in different k's and how you're using things. Okay, I'm going to keep working with this. This ck plus 2 is going to be bk plus 1, and this bk plus 2 is going to be a k plus 1 plus 2c k plus 1 using this middle fact. Okay, it's looking pretty good. I just need to think about the left hand side. Left hand side is a k plus 1 plus c k plus 1. I'm fine with those. I'm trying to write everything in terms of k plus 1 variables. and then the AK plus 2 and the CK plus 2 need some work. My handwriting is so bad that I can't tell apart my 1s and 2s, and that's really messed me up here. That's AK plus 1 plus CK plus 1. I'm leaving those first two terms alone. The AK plus 2 is C at the previous coefficient, and that C is the B at the previous coefficient, which is exactly the same. That's the right hand side. Okay. Oh, that was not too bad at all. I'm doing it this way is much better. Just keep going until all the subscripts are K. We can keep going until all the subscripts are 0. Just keep going. I should not have changed BK plus 2. I see that now. I agree. That was correct advice. Thank you.